Good afternoon. This is the second part of neural network, artificial intelligence subject. We had the first part, and this is the second part. Biological foundations and the McCulloch-Pitts neuron. So the human nervous system is the biological inspiration for artificial intelligence. So from this McCulloch-Pitts neuron, the artificial intelligence advanced. So biological neuron can be viewed as a three-stage processing system, kind of information flows through the system in feed-forward and feedback loops. So we've got receptors, which collect environmental stimuli, for example, photons, and we've got brain or neural network. These are the central processing unit or CPUs that can analyze or process data. And we also have effectors, which are the output mechanism that interact with the environment. Here, the brain itself, it has several components. From these several components, there are two levels or two layers, whereby a crude approximation taken from them to have artificial neural network. And these are neurons and local circuits or small groups of connected neurons. So the 7 layers, I go through them. First one, molecules and ions. Second one, synapses. And then next, neuronal microcircuits. And fourth is dendritic trees or dendrites. Then fifth is neurons, individual processing unit, cells, local circuits, and then interregional circuits, and finally, central nervous system. This is a biological brain. This is a biological neuron. It has 4 parts. The first part is dendrites, accepts input. Second part is soma, process the inputs. And third part, axon, which turns the process inputs into outputs. And then we've got the last one, synapses, the electrochemical contact between neurons. Some differentiation between biological neuron and artificial neuron. Well, biological neuron operating system can be in terms of milliseconds, whereas artificial neuron, it'll be in nanoseconds. Okay. Biological neuron has high energy efficiency. The artificial neuron has lower than that. Processing units, biological neuron, it processes around 10 billion cortex, whereas artificial neuron processes tens of thousands. Connectivity, thousands of connections. This one high. And then evolution, it took millions of years to get human brain developed and advanced, whereas neural network started in early 1940s, exactly 1943, by McCulloch-Pitts. So we can call it tens of decades. McCulloch-Pitts, 1943, as I mentioned, the first mathematical abstractual representation of a biological neuron. And here is some notation: X vector, which has X1, X2, X3, and Y vector likewise. Sum of X, it gives you this one, sigma Xi, I from 1 to N. If we sum up X vector with Y vector, that's how we do it. And if we dot them, X multiplied by Y, that's how we get it. Neural networks, they work with weight matrix, could be M by N matrix, 2-dimension. And these weight matrix first initialized, and then later on will be settled, and the network will be tested upon. Now, if a weight is positive, that is excitatory, and if a weight is negative, that is inhibitory. And there's also a threshold, a predefined value that the neuron's total input must reach in order to activate. So here is Y equals function of the net of the of any neuron, which is Wi multiplied by X sub I. I goes from 1 to N. Now, if this net, we call it V, which is function of V, that's Y. If that V greater than theta, a threshold, then 1, greater or equal, this net will be considered 1, classified as 1, or smaller than theta, which is 0. Here is a sine function. Again, the net that we talked earlier in the previous slide, which is X or F or Y, function of V or X. So if X is here, X is here, so that value all the way from here is 0. While if your X is in here, so this is 1. And you can see that's 1. That's 0. So anything here, X, anything here, it will be 0. And X, anything there, it will be 1. So classified as 1 or 0. X would be 1 if the net greater than theta threshold. Otherwise, out is 0. The McCulloch-Pitts neuron can simulate basic logic gates by adjusting weights and the threshold. AND gate, if we represent it with 2 neurons and 1 output. So for AND gate, if you want this output to be 1, these are inputs. So to get output 1, they need both inputs. The net of input should be kind of greater than 1. So theta, weight 1 should be 1 and 1. And then if you feed 1 and 1, 1 multiplied by 1, 1, 1 multiplied by 1, 1. Sum them up, that is 2. 2 greater than theta, yes, that gives you 1. So that's basic idea of AND gate, and there's also OR gate condition. For OR gate condition, you need one input is 1, and the output would be 1. For NOT gate, inhibitory. So inhibitory inputs act as a veto mechanism. If inhibitory input is 1, so the neuron does not fire, and regardless of other inputs. So if it's 1, then it will be 0, and if it is 0, it will be 1. That's more or less about today's class. Inputs and outputs are restricted to 0 and 1. Fixed weight, it means that there's no learning algorithm, and all neurons updated their states simultaneously at the same time. So stay tuned for the next class, and thank you very much. Bye.